IPv6. The first one, we will discuss about IPv6 first. Then we'll see IPv6 and IPv4 differences. Okay. So difference is very important. Okay. So that's why discuss. Okay. So IPv6 is 128 bit. Okay. 128 bit. IPv6 is 128 bit. Means in zeros and ones combinations, so totally 128 bit. Okay. IPv6, it's a 128 bit. Next. Total number of IPv6 addresses. Total number of IPv6 addresses is 2 to the power of 128. Okay. It is approximately 3.4 billion IP addresses. Exactly, it means 3.4 into 10 to the power of 38. Means put 34, after 34, put 37 zeros. After 34, 37 zeros. So you have to put a commas and all. I can calculate how many billions wise or crores wise also. Okay. It is very huge number of IP addresses. Huge number of IP addresses are there in the IPv6. But of course, worldwide, we are using almost like only the released IPv6s out of total IPv6 not released into the public. Only 1/16th part, 1/16th part of IPv6 only released in a different categories wise. Okay, in a different categories. And in a IPv4, so in IPv4, the total number of IPv4 addresses are 4.3 billion IP addresses total. Out of that one, 2 classes of IP address we are not using. We are using class A, class B, class C. In that one also few addresses we are not using. Okay. So it is not a bigger one. So even you will get less than 4.3 IP addresses, right? So 1 to 126, 128 to 191, 191 to 223. That is the total range. Both private and public IP address range we are using. And that one network is there, a class B network. That is again separate private, which is generally we don't use it for communication purpose. Okay. So if you calculate like that, it is much lesser than total number of IP addresses. Okay. Okay, it's not 4.3, it is less than 4.3 billion only. But in IPv6, the total number of IPv6 addresses are itself, it is very huge, for 3.4 into 10 to the power of 38. Okay, those many times of things are there. Next, this IPv6 address represented in hexadecimal format. Hexadecimal format. One hexadecimal format. One hexa is equivalent to 4 bits. One hexa is representing with 4 bits. Like hexa numbers are from 0 to 9, A to F. It is not alphanumeric number. It is not a alphanumeric number. Alphanumeric means there is a letters and numbers called alphanumeric. But this is not alphanumeric. These are all considered as a digits only. A is also digit in a hexadecimal digit. F is also hexadecimal digit. Like A is like in a decimal format, it is a 10. F is a 15. So it is start with a 0 and end with F. It is means totally 16 numbers are there. Okay. If you write A into the hexadecimal binary format, it is 1010 binary. Okay. B is 1011. Okay. F is all or ones. It's a single digit. So single hexa number digits representing with the 4 binary points only. So that's why it is this IPv6 writing into the hexadecimal format. This one single hexa represents with the 4 bytes. So the total IPv6 is 128 bit, right? One single IPv6 address is 128 bit. So you're representing in hexadecimal format means 128 by 4. 128 by 4. How much it is? 32 hexa numbers. 32 hexa numbers in a single IPv6 address. If you take one single IPv6 address, totally 32 hexa numbers. 0 to F numbers. Okay. Next. 32 hexa numbers. These 32 hexa numbers divided into 8 blocks. Divided into 8 blocks. This total 32 hexa numbers divided into 8 blocks and separated by colon. 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 Okay. It means each block contains 4 hexa numbers. Each block contains 4 hexa numbers. Okay. So how many blocks are in IPv6? 8 blocks. Each block contains 4 hexa numbers. So 8 into 4 is 32 hexa numbers. So each hexa number represents with the 4 bits. So 4 into 32, 128 bit. It's the first calculation. Okay. You can write like an example of IPv6 address. You can write an example of IPv6 address, or maybe like 2001 colon. So this is one block. This is one block. 0, 1, A, 4. Yeah, anything you can write like this. 0, 0, B, 2, 0, 0, 0, C. Okay. D, 0, 1, 2. Okay. How many blocks? 1, 2, 3, 4, 5. So okay. Like this. So totally 1, 2, 3, 4. Okay, 1, 2, 3, not yet completed. Oh, not yet completed. Okay. Okay. 4. Another 4. Totally 8 blocks. Total it is 8 blocks. See? And IPv6 is secure. There's a few more points about IPv6. Compared to IPv4, it is a IPv6 is secure. So very important is their security features. Means when you are sending your data, right? So you can keep some encrypted keys. Okay, that key related information you can integrate inside your IPv6. Okay, so you can like a key matching features are there for secure communication purpose. Second one is ISP integrated. Okay. So because when you take an IPv address, if you want an IP address, right? You want a public communication IP address. Okay, for your organization or for some internet service provider, anything for an organization, any IP address kind of stuff. Okay. So we are registered with the IANA, Internet Authority Number and Assignment. Right. So the regional office, which is a regional office, so we have to go to that regional office. Okay. So you have to register. These are the public IP addresses are required. I need a public IP address, so then we will get it. Or from your ISP also you can request it. Example, you want a website. What you will do? You need a domain name. Website for website, you need a domain name and domain hosting servers are required. So instead of doing yourself, you to purchase a domain name, you can buy a domain name from ICANN, regional ICANN centers. Okay, you have to register personally. Instead of doing that one, you are buying from Big Rocks, GoDaddy. So you are buying a domain. Even Amazon, from Amazon also, you can purchase a domain name. That's the $10 it is. Okay. So what I'm saying is instead of that you like that. So instead of registering with ICANN directly, so IANA, so then you go with your ISPs also. Again, in IPv4, it is, the IPv4 public communication IP addresses. Everything is controlled by IANA. Again, it's like these ISPs. So separate networks are given, public networks are given. Okay. But we don't know which ISP this IP address is belongs to. Okay. So then it's very difficult to identify which area, which ISP this IP address belongs to. But with IPv6 is more clarity because in the IPv6 we are integrating ISP related code also. Okay, ISP related code. Your keys, security keys, integration key informations. Okay. Um, check some data. You are sending a packet. Generally, in data link layer, we are adding this checksum data, CRC data. But in IPv6, we can integrate the checksum data also for make sure that is data is good or corrupted verification purpose. Okay. So these are different integrations are in a IPv6 also there. There is a rewriting of IPv6 part also there. If any possible, I will going to um, okay. I'm going to uh, so if possible, we are going to see that one. But this is simple one IPv6 address. I'm going to write one more IPv6 address 2001 colon A, for example, colon A. This is also one IPv6 address. Okay, colon A. Colon 1. This is also one IPv6 address. Colon 1 means it is a loopback ID. In a IPv4, you have a 127.0.0.1 as a loopback address. Here it is colon 1. Okay. So that's an example of IPv6 addresses. Secure integrated ISP information, RSA means this encrypted key information. CRC checksum data integration is there in the IPv6 address, mainly in the public based communications. Again, guys, in IPv4 we have a classes are there. Total IPv4 address divided into 5 classes. Class A, class B, class C, class D. Okay, each class having a class range is there. Class D is a multicast address. Class E is we don't use for anything. Okay, class. Okay, it's like a R&D type, means it's not released into the market. It is not released into the public. Okay, class D is a multicast address. Class A, class B are unicast. In that one also there is a 169.254, an automatic assigned IP address is there. That's called API address also there. And 127.0.0.1 is a loopback address. 0.0.0 is unknown or a reserved IP address, unknown IP address, or allow all, deny all representation. Okay, like certain protocols using that one, of course. And in IPv4, some addresses are for public communication purpose, some IP addresses for only for private communication purpose. For example, in my organization, I have a systems. Within this system, people should communicate each other. That's it only. Then I need a private IP. These private IP addresses not routable in public. With private IP, you can't communicate in the internet. Okay, like google.com, facebook.com, you can't access with your private IP directly. Means whatever the laptop, your laptop IP address, you connected to internet, what is the IP address of your system? You are asking Google, but Google don't know what is your system IP address. Google knows your public IP only. So your ISP handling that public IP only. The system don't understand what is your private IP. Okay. So with the private IP, again, with the private IP, you can't communicate publicly. So in IPv4, some IP addresses are private IP, some are public IP. We will see that one. So just note. So similarly, but no specific division in the IPv4. Okay. But in IPv6 is completely, there is a different categories are there. In IPv4, we are divide entire IP address range into the 5 classes. But in IPv6, we didn't divide entire IPv6 into the classes. So we specify certain ranges for specific purpose. Specific purpose. Example, for a public communication, there is a range is there. So global unicast address. Global unicast address. So that's start with the 200 colon. So remaining are all are zeros only. Okay, it's the starting one. And up to 3 F, 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 and remaining are all F's only. All remaining are F1. So that is this is the starting and this is ending. This complete range is global unicast address, and this is used for public communication. Okay, this is used for public communication purpose, like you're accessing internet, google.com, facebook.com. So you should be ranging this one only. Okay, this sometimes represent like this 001/3. Okay, so what is this /3 kind of stuff? In the binary, this is 001 is in a binary one. 001/3 means this 001 is a constant from entire range. So that's why this ranges came up. Okay. Of course, deep explanation is there, but still, what are the basic things? Public IP address for public communication. Like you are accessing google.com, facebook.com, youtube.com. You need a public IP. Okay. To use this public IP, again, you have to need a registration. Okay. Next is private IP address range. So here, private IP address are not routable in a public. It is useful only within an organization. It will be routable, private to private, routable is there, but private to public, direct routable is not there. Okay, we can't communicate with our own IP address to public. Okay, private IP address range. I have to check once. It's a FC00 or something like. Yeah, it's FC00. FC00. So this is my private IP address. Public IP address, private IP addresses. My interesting one is link local. Okay. So this link local, not routable. This is non-routable type. Means you cannot communicate between different networks kind of concept. Okay. This is the range is FE 80 colon colon. Okay. FE 80. Okay. FE 80 colon colon. This is link local system auto-generated IP address. Every system, if they're in their adapter settings, IPv6 is enabled. So automatically an IP address is assigned. With this link local, within your own single segmented network, within the segmented network, means physically, logically, same network. Physically, logically, same network. It's a single segmented network. Okay. Within the segmented network, you can communicate each other without assigning any IP address separately with the help of link local. Every system, you can check your laptop also. If IPv6 is enabled, you can see this link local IP address showing FE80 colon colon some numbers like a, okay. So that is with that IP address, you can communicate between the system if both systems are in the same physical network. Okay, in same segmented network. But if your other network, if you want to communicate a system which is not in your physical network, directly not connected to your same network kind of stuff, same segmented network, means you have to cross to the router, you have to go through the router and you have to reach the destination. So then you can't communicate with the link local. Okay. And of course, IPv6 FR, it's stateless, works in the stateless mode. Works in the stateless. Global Unicast, private, link local. What are other things are there? Multicast. Multicast. One more is there called Anycast. Okay. This Anycast is like a broadcast only. Like a broadcast. What is meant by broadcast? Send packet to everyone. In IPv4, we have a broadcast. Two types of broadcast are there in IPv4. One is to everyone, irrespective of what network there are belongs to, what logical network there are belongs to, we can able to broadcast to everyone, all connected devices. Like a destination address is 255.255.255.255. It means it is a universal broadcast, means your broadcast packet to everyone. Okay, irrespective of what is your right destination. We don't know who is the destination address. Then we broadcast in certain situations. Okay. like a DHCP client use destination address is 255.255.255.255 to find the DHCP server as a destination address, broadcast address. Okay. In IPv4 is your in any IPv4 IP address network. The very first one, last class we discussed, no, very first one is network ID and very last one is broadcast ID. Within the logical network, you want to broadcast a packet, we use that broadcast ID. In IPv6 is different. It's use Anycast. What is this Anycast? Anycast is like a broadcast. It broadcasts the packets to every device in the network, but only certain devices only. To whom? If in case the destination device, the connected devices are enabled with IPv6, only to that systems only. If the devices connected in the network, if they are enabled with IPv6, means IPv4 and IPv6 both are enabled, or IPv6 only enabled also, they will get the packets. But if a device connected in your network, only IPv4 is enabled, IPv6 is not enabled, it means that device won't get any packets. That is Anycast. Multicast, it is FD 00. FD, FF, sorry, my mistake. FD is private IP address, complete range. FF 00 range. Okay. FC, FE, FF, so multicast range. Anycast is, I'm still a little confused. It's also showing 2001 only. Okay. So that's a Unicast range. So in IPv4, we have a 0.0.0.0. In IPv6, we write this one as a colon. In IPv4, we have a loopback address 127.0.0.1. In IPv6, it's just a colon 1 only. Okay. So this is about a IPv6 address. Yeah, here it is written. Okay. So again, IPv6 is 128-bit. So 3.4 into 10 to the power of 38 number of IPv6 addresses are there. It means in the worldwide, you can assign for at least one device, like even a mouse, keyboard also, you can assign IP addresses. IPv4 has a limited range only, but IPv6 is a practically unlimited range of IP addresses. There is a limiter, but really it's unlimited. So many IP addresses we are getting from IPv6. And IPv4 is represented in a decimal format. IPv6 is represented in the hexadecimal format. Okay, we'll go to the differences, guys. IPv4, IPv6 differences. IPv4 32-bit, IPv6 is 128-bit. IPv4 4.3 billions of IP addresses, whereas IPv6 is 4.3 into 10 to the power of 38 IP addresses. IPv4 is decimal format and IPv6 represented in hexadecimal format. Total IPv4 is divided into 4 parts. Okay, each part we are calling as octet, means we are having 4 octets separated by colon. In IPv6, we have a 32 hexadecimal numbers. So total IPv6 having 32 hexadecimal numbers. These 32 hexa numbers are divided into 8 blocks. So each block contains 4 hexadecimal numbers. Each block is separated by colon. In IPv4, so we have 8 octets, right? So sorry, 4 octets separated by dots. Each octet range is 0 to 125. Where IPv6, Each block, so totally 8 blocks, each block contains 4 hexa numbers only. And IPv4, the total IP address range is 0.0.0.0 to 255.255.255.255. This is the total IPv4 range. In IPv6, the total range is 0000 colon 000 colon 00 colon like that it will be there. Okay. Really, if you want to write total range, I'm not like to write, but it is very bigger. We need something, so like a notepad is quite better. So where it is, 00, one block, four blocks. Okay. Is it completed? 32. 1, 2, 3, 4, 5, 6, 7, 8. So this is the starting one. So actually, if you want to write, okay, what happened? This is 1, this is 2. Okay, it's not binary. It is total hexa numbers only. You know, what is the last one is F. Okay. So this is the last one. This is total IPv6 range. Like you go on 1, 2, 3, 4. Okay. So you reach sometime it is like this. You reach all our Fs. Then what happened? 1 colon 0 0. Okay. So it is keep on going. This is the last one. The totally it is 3.4 into 10 to the power of 38 number of IPv6 are there. But we are not dividing this entire range. In IPv4, we dividing entire range. In IPv6, we didn't divide in entire IPv6, we didn't divide. We are specifying certain ranges for specific types of communication purpose. Coming to the IPv4, so we divide entire range into 5 classes: Class A, Class B, Class C, Class D, Class E. The Class E is reserved not for a public purpose communication. Okay. So in a Class A, Class B, Class C, Class D is a multicast address which we can't assign to any devices. In a Class A, Class C, Class C, again this 0.0.0 which is reserved, used by certain protocols for certain different purposes like default routing, LOR, denial, DHCP, client access purpose like that. Anyway, the zero network, we are not using it. 127.0.0.1, which is used for loopback address. Okay, self-testing purposes, right? Other than that, 1 to 126, 128 to 191, 192 to 223, these are all we can assign IP address. But in this one again, so there is a private IP addresses and public communication IP addresses also there. Example from class A, okay, where is it? Yeah, here it is. From class A, this 10 network is private communication purpose. Within the private, without purchasing or registration, okay, you can use these private IP addresses for your internal use. Okay, so it cannot be routable in public, means with public private IP, you can't access internet. So this is class A. From class A 10 network, from class B 127.16 network to 172.16 network to 170.31 network. All these network, like a total 16 networks are there. 172.16, 170.17, 170.18, up to 170.31. This total networks are belongs to private only. And class C 192.168.0.0 to 170.168.255 network. Okay. So it's a totally 256 networks from class C. 192.168.0 network. Okay. 192.168.255 network. These are all network ranges belongs to private range only. Other than these private IP addresses, and there is APIPA 169.254, except remaining all belongs to the public IP addresses only, which is controlled by IAN registered, paid, okay, which is required to be registration. Payment is also there, okay, and mainly used by organizations. So this is about a private IPv4, whereas in IPv6, we divide entire IPv6 into classes. But there is a specific ranges for different purposes. So private communication purpose, FC00 is a series. FC00 by /7. This range is non-routable in public. The range is not routable in a public. Okay. You can use without registration or payment license. You can use within your organization in the range of FC00 range. Next, link local. Link local is a purest of private. It means, so in a private IP addresses can be route between one private to another private network if it is connected through router directly. So one network is private IP, you configure. Another network is there, you are connected with a private IP address. You want to make them communicate each other, then you need a router. So, if within a private, within your organization, like a LAN, CAN, MAN, so you can use this private. Within that, we are able to communicate. Okay. And the link local IP addresses, FE80 range, non-routable in private as well as a public also. Means, so in one network, so you completely use this FE80 only. But in another network, which is outside of your router, okay, you want to communicate, you can't. Okay. Within your own single LAN, single segmented network, you can use FE80. Okay, one second, guys, just no, a minute, half a minute. So, okay. Where are we? And this link local, we are not assigning to the any devices. Again, the link local IP address, we are not assigning to any devices. Okay. And this link local address is automatically generated by our system only. Okay. Which is used to communicate within your segmented network. Okay. So I'm taking IP config, IP address. See, IP address, subnet mask, and default gateway. Of course, can you see link local? Link local. Link local means FE80. With this IP address, this is system self-generated IP address based on this adapter's MAC address. Based on this adapter MAC address, system self-generated IP address. Okay, based on this MAC address, where is this link local IPv6 address is generated. Okay, so this is the one. Okay. Of course, I got IPv6 address here because I am in home. My internet is Airtel. Okay. So Airtel is using IPv6 also. It will use both IPv4 as well as IPv6 address. Okay. So link local means system self-generated IP address based on the adapter's MAC address, which is used to communicate within the segments only. Okay, the link local IP address, the starting FE80 colon. Okay, which is you can't, not routable for public. With this IP, you can't communicate to the public network as well as within a private, non-routable in private and non-routable in public also. You know the multicast address. So multicast address is for multicasting purpose only. So between the different protocols or share their information between the devices, okay, to share the information if the similar kind of protocols are enabled, like a routing protocols. Another one is Anycast. Anycast is like a broadcast, but only IPv6 enabled devices only. In IPv4, we use broadcast. In IPv6, we use Anycast. Okay. In IPv4, to represent the start of IP, it means unknown IP network or LOR deny all. Okay. So we use this 0.0.0.0. In IPv6, we use just colon. In IPv4, we use loopback address is loopback or localhost address is 127.0.0.1, whereas in IPv6, it's just colon 1. Okay. Next. Guys, in IPv4, we divide a network portion and host portion using subnet mask. With help of subnet mask, we can divide network and host portion. So, of course, whether it is IPv4 or IPv6, there is a network representation and host representation is also there. But in IPv4, we use subnet mask for specifying this, what is the network and host portion of IP address. In IPv6, we don't use this subnet mask. Okay, but we are using the prefix. In IPv4, you can use subnet mask and prefix. In IPv6, it's only prefix method only. Prefix method. Okay, to represent prefix methods or no slash notation method to represent network portion. If you see there is an IP address, see written some IP address /64 means first 64 first 64 bits in a binary, first 64 bits are belongs to network portion. The next 64 bits belongs to host portion. If you see in this network that 64 bits are host portion, means 2 to the power of 64 is number of hosts we can connect in the network. Okay. So if you go back to the IPv4 in a class C, the host portion is only 1, means 8 bits are host portion. 2 to the power of 8, 256 minus 2, 254 in a class C. 254 devices you can connect in the class C. Next is class B, 2 host portions, means 8 plus 8, 16. 2 to the power of 16 minus 2 is a 65,354 devices you can connect it. You go to the class A, is 3 host portions, means 2 to the power of 8. 2 to the power of 24 minus 2, it is 16 million, 16 million, 214 devices we can connect in a class A network. The number of hosts are 24 bits only. Host bits are 24. We'll go back. Come here. 64 host bits, 64 network bits, 64 host bits. So think like how many hosts we can connect in one single IPv6 network. Okay, so it's a 2 to the power of 64 minus 2. You have to calculate like that. Okay, so this is the pure point about your IPv6, guys. So first is IPv4 and next is IPv6 and about IPv6 and difference between IPv4 and IPv6 is compulsory. Okay. No one will ask you what is IPv4, explain IPv4, but IPv4 classes are important. IPv4 classes important, subnet mask important, what is use of subnet mask, what is subnet, what is subnet, what is subnet mask is an important point. Next, okay. But IPv6 and IPv4 difference is very important. So for that one, compulsory you have to read about both IPv4 and IPv6. IPv4 and IPv6 differences are important. Next one is, guys, IPv6. So the few are the points I told like security, okay, encryption, key integrations, okay, checksum data integrations, ISP information also integrated in a IPv6 addresses when you are connected to the internet public connections. Okay, of course, yeah, the link local IP addresses kind of stuff. Okay, good. Um, yeah, there's some other features like why entire world is using IPv4 or IPv6, which is more benefited like that. Guys, IPv6 is also faster than IPv4. IPv6 is one single IP address is very big compared to IPv4. IPv6 is very big IP address, right? But still it is faster. Why? Because of it represented in hexa number. Hexa to binary conversion is quite direct. So if I want to write this IPv4 address 192.168.1.34 into the binary format, it take a time. But an IPv6 is don't take much time. See that 2 means 0010. 0 means 4 zeros. 0 means 4 zeros. 1 means 3 zeros 1. 2 means 0010. Okay, 3 0011. 4 0100. A 1010. B 1011. 6 1010. C 1100. Okay, 20010. Directly we can write. But you come back 192. 11000000. 168. That again we have to check it. 168 means again 1. Okay. Few are easy to directly conversion, few are maybe like people. So to tell also you need a habituated to that. But again 120, 168 or 192 or 1 or 34 need to be converted. One we can easily convert it. Not only ourselves guys, even system also, the conversion from decimal to binary is little difficult, but compared to hexa. Okay. So that's why it is faster. IPv6 is faster, secure also, strong. Okay. And it is bigger the size. Bigger. Total size of IPv6 is also very big. And one network. So in one single network, 2 to the power of 64 by on. Okay. On average means in most of the cases, in any single IPv6 network, 2 to the power of 64 devices we can connect. Approximately 2 to the power of 64 devices we can able to connect it, one single network. So it means one single network is, so billions of devices you can connect it. Okay. So 2 to the power of 24 itself 16 million. Think about 2 to the power of 64. So 2 to the power of 32 is 4.3 billion. 2 to the power of 64. Okay. It is very big size. Next. Okay. So IPv4, IPv6, the differences. Number of 4 octets here, and here it is 8 blocks. It is separated by dot, it is separated by colon. Okay. And the IPv4 classes and IPv6, this specific ranges. Okay. So these are the differences are important. Again, what where I'm missing. Sorry. Yeah. IPv6 globally, entire globally, IPv6 are not using. Okay. Still we are using IPv4 globally. Why? Because certain countries still there are using IPv4 based network only. Certain countries and certain private organizations. Okay, so there are still using IPv6. That a new kind of organization came into the business. They are directly using IPv6. Okay, certain countries like Germany and Japan. Okay, so this type of countries they are using complete 100% IPv6 addresses for their in the internal communication. Okay, so we can blame. Okay, like India is a very old. Okay, okay, people are telling no, guys. Even US, like the network, all this concept actually we started from US only, right? Okay. So in that in these like countries like US, UK, Australia kind of countries itself, they're using IPv4 only because there are systems are very old systems also available. Certain organizations, certain departments still the old configuration setups still they are working with IPv4 only. So to move into the IPv6 totally, it will take time still because this old system should be replaced with a new one. It's very high, costly, and challenging one. And next is IPv4 system to IPv6 system, IPv4 only system to IPv6 only system. It's very difficult to communicate. They can't communicate each other directly. One system I configured IPv4 only. In other system only IPv6 I configured. They can't communicate each other. They don't understand each other. To make a communication between IPv4 to IPv6 devices, IPv4 network to IPv6 network, you want to communicate, we need a converter. 624 converter, ISA tab converters are required. There can be router or a server which maps your IPv4 address to IPv6 like that and IPv6 to IPv4 kind of stuff. Okay. So these are the difference between IPv4 and IPv6. So as I said, guys, explain it about IPv4 may not be there, but still when you are comparison, so comparison is a compulsory question. So when you do comparison, you must know each and every point. Okay. So that is why it is very important to know each and every IPv4, IPv6 individually. Okay, so what you do, take just a 10 minutes break. We'll go back to the private IP address and NAT and PAT also we'll discuss. So morning session will complete this IP addresses part. Okay. Any small things also we're going to complete. So take small break. Back in 10 minutes, like